All right, thank you. Thank you, Dr. Okonkwo. You cut into my time a little bit, but that's cool. I did graduate from Westover. I did graduate from ASU, and graduate school took me 6 years. So it's a long process, but that's not really what I want to talk about today. Today I want to talk about graphics, basic statistics, and something called text mining. So let me just start. And I'll be asking you questions. You can chime in whenever you feel like it. But I'm going to start with this first graphic here. So this is basically a graphic from pop culture, right? I mean, how many people have used OkCupid or maybe another kind of social dating website or app? Nobody? So y'all are old school. I date in person. I don't use Tinder. You don't use none of that?
I use Snapchat.
You date through Snapchat?
I mean, you shoot your shot on Snapchat.
Okay, all right, cool. That's cool. That's cool. So this is a graphic about basically the sort of quick matching or sort of dating profiles for people who use OkCupid, right? So it's distributed by race for men and women. So we have the first graphic at the top is men who are rating women, okay, on that dating app, and we see it spread out by race. So if you look here, right, this, what do you see in that top graphic? Like what sticks out to you? Say again?
Why are the black women in red?
Why are the black women in red, right? That's kind of a weird, that's interesting, right? It's, so what's happening here is black men, or at least every group of men, right? If you stratify them by these 4 racial categories, every group of them is rating black women based on their matching as really low. Meaning people who use OkCupid in a general sense don't really see it for black women. And I was wondering, that's why I was asking, like, what do you all think about it? Because, I mean, a lot of black women are here, right? I mean, it kind of goes back to that Grownish episode, like a couple weeks ago, right? Where they're talking about dating and how it's a struggle for black women in particular, right? So the data supports that, right? They use the little graphics and stuff in that show too, but the data is saying that basically, for some reason, right, we don't know why, and maybe I'll ask you, but for some reason, black women are not valued in the kind of dating sense. You have a question? Okay, who are these men?
Who are these men? Are these men Chinese, Japanese, or what? Because, and take this lightly because I want to make a little, the OkCupid, who are the predominant type of men who go there? Are they mostly white, Chinese, Japanese?
Oh, thank you.
Because if the data was collected from blackpeoplemeet.com,
right.
the results might be different.
Maybe, right. So we don't know, right? I mean, as far as who's using the site, I mean, we have the stratifications here. So all racial groups are represented in terms of if they actually use the site, right? So there are black men using the site, there are Asian men, white men, and Latino men, right? So they're definitely in the data set, but like you're saying, maybe in a different website or different dating app, maybe the results might be different, maybe not, right? I think that show, right, was trying to get at a deeper maybe issue, a cultural issue, right? Like in terms of black women not being valued. And if you look at, but look at the opposite, right? So look at women who rate the men, right? Like what do you see happening here? What do you see that's interesting happening in the bottom graphic? Anybody can chime in.
Black women rating black men high.
Relatively high, right? Actually, so what we see is we see this diagonal of all greens, right? We see every group when they're looking at at least for women, right? When women are looking at potential dates, we see that if they use OkCupid, we see that they tend to want to date somebody or rate somebody highly if they're in their own race, right? So that's really interesting, right? Because we don't quite see that for the men, right? We see the men tend to, at least black men, right, tend to, see it for other groups outside of black women. So I thought that was really interesting. Also, we see Asian men don't really fare well unless the women are Asian, right? So this is a powerful graphic. I mean, this is real data, right, being used, right? You're learning about basic statistics in class, right, in a kind of broad theoretical approach, right? But this is real data giving us real information that we can use, right? So think about like how this might be useful as a statistician. Okay, you're trying to work on, this may not be working on a project. Okay, this is another example of a data set, of a graphic. Basically, this is a historical graphic. So this was made in 1869. It's what a lot of people consider to be one of the best visualizations ever. Okay, what it is it's actually Napoleon's route. So Napoleon, the French emperor, okay, his route as he was battling Russia. Okay, and what we see here, the person who created this is named Menard. The last name is Menard, and what this is showing they're using time, temperature, geographic information to describe what actually happened in that battle. Napoleon, they got defeated. They got defeated pretty badly, but it wasn't just because he was an army against another army, right? There were other factors. Okay, and this graphic is showing, it's hard to see here, but it's showing some of those other factors. We have time, the weather was really bad in Russia. Okay, there were a lot of things that were battling against the French army at that time. Okay, and so this person is an engineer basically, and they drew up this graphic back in 1869. And then here's another graphic. Sorry, it's not the most clear in terms of, it's not very sharp, but I'll read the very top part. So it says, a new chart set to be released later today. This is back in, I think 2004. No, 2000, I forget what year, it might be 2012 or 2014. So later today by the Republican side of the Senate Budget Committee details a startling statistic. Okay, they call it startling. Over 100 million people in the U.S. now receiving some form of federal welfare. Okay, so when you look at the graphic, right, we see the red bars, they get higher, they get bigger, right? And so as a statistician, we think, oh, well, yeah, this is pretty bad, right? We see a lot of people are using welfare beginning from 2009 up until the second quarter of 2011. But can anybody, oh, okay, thank you. But can anybody explain or maybe poke at this graph? In other words, what do you see that may be a misrepresentation from this plot? Why might you say something different? Or maybe I should say, why does it, how can it be misleading from this graph? Just as a graphic. The population growth. Okay, not quite what I'm looking for, but that's something to think about though, right? Like maybe there are more people in certain years, right? Or certain quarters, but that's not quite what I'm looking for. Somebody else got an idea of why this graphic is misleading? Okay, look at the axes. Look at this vertical axis. 94 is 94 million, okay, meaning the number of people, okay, on welfare, right? And then the very top is only 108 million, right? That's a really small distance, a small jump, okay? But the graphic makes it appear like the jump is dramatic, right? You see a really small bar, and you see a little bit bigger, a little bit bigger, a little bit bigger, and then you see something that looks It just looks like it's getting really bad, right? But if I were to change this axis to 0, right, then these differences would appear very, very minute. They would all look like one line, okay? So this is a way that people, whether they're statisticians or sociologists or whoever, this is a way that people can use data, right, and graphics to mislead people, okay? This is what I would call a bad graphic, okay? The data is real, right, but the kind of dramatization of how bad the situation is, right, the startling nature of it is not really the case, right? It has increased, but it's not as dramatic as this makes it look, right? So what do we do? So as statisticians, or at least as a statistician, what you want to do is you want to make sure that the evidence, okay, and that the results are accurate and reproducible. Meaning, if you are working on a study, all right, and then you conclude that, I don't know, something like that, right, that there's 100 million people or over 100 million people on welfare, right? Suppose that's your conclusion that you draw, right? Well, for it to be reproducible, I need to make sure that if somebody else had the same exact data set, that they could do or get the same exact conclusion, right? That's what it means to be reproducible. So as a statistician, you have to make sure that what you're doing is true, okay? That is not a misrepresentation. So it has to be accurate and has to be reproducible, okay? And then as a statistician, you're also trying to provide interpretations or analyses that are going to be clear, meaningful, thorough, meaning you've gone from step A all the way to step Z, right? You didn't say, well, skip steps B through D, right? So be thorough, but be concise. So when I say concise, I'm saying, as a statistician, you're going to be working on a team of people, right? You're the statistician on the team. Somebody else is the scientist and the general scientist. Somebody else is the economist, all right? And then what you're trying to do is to play your role, right? Which means you can't overwhelm the team with information, okay? Even though it might be thorough and good, you can't just start spitting out information, spitting out facts, spitting out statistics, because some of that is not gonna be useful, okay? So you wanna be concise in the sense of giving an analysis that's to the point, okay? And also be truthful. Okay, you don't want to inflate, what's really happening in the data. Okay, and sometimes your results are not going to be meaningful. Sometimes your data is not that good, meaning you may not have that much of it. Okay, so to make stronger claims as a statistician or an analyst, you want to make sure you have more data or enough data. All right. So what I was going to do was talk through 2 different data analysis projects. So the idea is I have 2 data sets I'll talk about, and I'll kind of walk through or a couple ways to analyze that data, right? Oh, sorry, it's here. Okay, so first data set. So it's a jail data set. All right, I live in Champaign County, the town is Urbana. And this is a data set that was sort of distributed by the Champaign County Sheriff Office. Okay, it contains the bookings for, in particular, residents who are living in Champaign and Urbana, meaning we are trying to look at or analyze data on people who live in Champaign and whether or not they're being booked or kind of thrown into jail at a certain rate, right? We want to know information about that. All right, so this is covering a span of 6 years from 2011 to 2016. Okay, it doesn't have any personal identifying information, so you probably can't figure out who the individuals are in the data set, but maybe if you know that person, you might be able to piece that out if you know the date and the nature of the crime. Okay. And it does have demographic information, so it has stuff like race, sex, things like that. There's 7,067 rows, 37 columns. Okay, and the purpose here is to explore the racial sort of undertones or underlyings of the penal system. And basically, are black people being placed in jail at an alarmingly high rate? So what would your inclination be? You think that's true?
Yeah.
You say yes. Undoubtedly, yes. Black people are being thrown in jail at an alarmingly high rate. Anybody else? Is everybody just agreeing with this man? Yes? Yeah, all right, cool. Cool. So if that's our inclination, right? For instance, right, I told my mom I told my mom I was working on this, and she was like, well, yeah, of course, right? And she was like, she threw out a number. She was like 90% of black people are in jail, you know, basically beyond the other kind of racial categories. And I was like, but you need evidence, right? You can't just throw out a number like 90% with no data, like nothing to support that kind of statistic, right? So the goal here is to look at the actual data we have and to see what's really happening. So this is just a snapshot of the data set itself. All right, we got booking dates, race, it shows the race, sex, citizenship. Citizenship is an interesting one because in our county, it's Urbana is a sanctuary town. So there's a lot of people who are, you know, not legal citizens of the U.S., right? So that might be an interesting project for you to think about if you had this data set. All right, it shows the age of arrest, meaning what age the actual person is who was booked, how long they were in jail, so the days in jail, and then the hours. So sometimes you might be in jail a certain amount of days and then plus X amount of hours, right? Or you might only be in jail 0 days, but you're in jail for, you know, up to about 24 hours. So you might want to play with those two variables to figure out a more accurate way to tell time, like how long you were in jail. We have the reason they were booked, the offense level, and then we have crimes that we can show as well, and other variables as well, okay? So some questions you might think about with this kind of data set if you're working on it. You know, what's the frequency of bookings for young men versus young women, right? You know, are men being thrown in jail more than women, or are they both kind of about the same? You know, are young people being thrown in jail more than old people? Are young people, you know, are black people going to jail more than white people? Or black people going to jail more than any other racial category? Okay. Another idea is there a relationship between the number of days you spend in jail, right, and the age that you're arrested? In other words, you know, are younger people tending to stay in jail longer, right? Or are older people tending to get out of jail, you know, sooner, right? Is there a pity kind of thing happening where people say, oh, you're 80 years old, you're drunk, you're belligerent, I'll let you go, right? But maybe if you're 18, you're drunk and you're belligerent, maybe you get punished more severely, right? So this is some questions you can ask from a statistical standpoint. And then basically what kind of graphics can we show with this type of data set? Wait, sorry, I'm going the wrong way. Okay, so what is data analysis? Basically, we're trying to make insights, okay, or decisions about a data set, all right? Data sets show up in structured forms, generally, as matrices or data frames or arrays. All right, arrays are just multi-dimensional data frames, or matrices, I should say. Okay, we have quantitative, qualitative information, which means that information can show up as words, nominal categories, or it could show up as numbers, right? And so when we say we want to work with the data, what we're talking about is transforming it, assessing it, cleaning it, modeling, you know, several different things we can do. And the usual procedure is you want to start off with some goals. So, any project you're working on, you want to have some goals, even if you only know very little about the data set itself. As a statistician or an analyst, you want to say, here's what I know about my field. Let me try to work on that with this data set, right? So set goals, look at the data, do like a real basic data, observation, inspection. Clean the data if there are any errors, all right? Meaning maybe one of these people in this jail data set has like an age at arrest of 0. Meaning for some reason, whoever was in the original, system didn't correctly put in their age. So you might want to remove that observation because it's not going to be of much use, right? So you want to do some cleaning. You want to analyze that data set, okay, based on your goals that you set. And analysis usually looks like basic data description and using a particular statistical method. And then you want to make some conclusion, okay? So there's free data analysis software you can use. If you're ever interested, there's R, which hopefully I'll get a chance to show you a little bit of. And then there's Python, which is all the rage nowadays. So if you want to get a jump start, if you're thinking about graduate school, I suggest you definitely work with both of these programs, but especially the bottom one, Python. Even I don't have that much expertise in it, but it's a big deal, right? So think about that as you're kind of dwelling or kind of getting involved in programming. Is anybody like good at programming, like in a different kind of program or software? Only 2? Okay. Okay. So here's a basic data description. Suppose I was interested in the age at arrest, that variable. All right. This is, what is this called? This graphic. The basic stat people, what is this called? All right, this is called a box plot or a box and whisker plot, right? So what we see here is the distribution of a particular variable. In this case, it's the age at arrest, right? So age, nobody's age 0, right? But we have ages, I just put the axis starting at 0, and we have people as old as almost 80 years old who have been arrested in this county. Okay, so if you know what this is a box plot then, so what is this black line? Somebody said average. Did somebody say something else? What'd you say? No? So so it's not the average. What is the black line? If it's not the average, what is it? Somebody say something? It's the median. The median, okay? Meaning the 50th percentile, basically, of the data set, meaning the exact middle of this distribution. Meaning there are 50% of the observations are above and below this particular value, right? So the median age is kind of upper 20s, maybe around 30 years old, okay? So if that's the median, then what is this green triangle? Somebody said it earlier. It's the mean, right? The average. The mean is the green triangle, yes. Okay, so what we can do with this distribution then is we can describe the shape, right? So we have our minimum value here, right? We have well, technically it's not the minimum, but we can think of it as the minimum. We can think of this as the maximum. These are our whiskers, okay? Or our sort of, supposed maximums, right? Our reasonable maximums. We have our third quartile here, our first quartile here. Okay, so when you look at this distribution, you can talk about the shape of the box. Is it very elongated or is it compact? Is this box elongated or compact? Compact, right? It's not very long, right? So the spread of the distribution then is pretty small, right? Most of the groups seem to be exactly below the age of 40, right? It's not a very widespread distribution, okay? Now, what are these dots, these circles then, if they're above what I call the supposed maximum? Exactly, outliers, right? So they're, according to this, so what's the rule then if we have outliers? How do we define them as outliers? Huh? It's the IQR rule, right? So we multiply 1.5 times the value called the interquartile range, and then that is actually what these whiskers are. And then anything beyond that are considered outliers. So in this data set, we have several outliers in terms of age, okay? This is another graphic. So maybe my mama was right, or at least she's not, wrong, I would say, right? She's not all the way right, but not all the way wrong, right? So that, and like, I think you as well, right? You were saying yes, right? So yeah, there's at least a lot of black people being booked in jail in Champaign County, especially a lot more than white people, right? Possibly there's a higher percentage of black people in jail than there are who live in the county, right? That's kind of what we call a disproportionate, okay? This is a little bit better graphic though. Can anybody explain why this graphic is better than this one? So this one is based on the counts. This one is based on the proportions. Why is the count not a good idea in terms of, why is it not as good to talk about than it is the proportions? So kind of. So the nice thing about proportions is we can talk about percentages, right? We can talk about sort of more accurately how this distribution is by race, right? We can say without a doubt there's about 65% of black people who are being booked in jail, all right? And about maybe 25% white, right? And you can say that with a little more certainty than you could if you were just looking at the counts, right? You can't talk about the percentage here, right? So if my mama showed me this graphic and said 90%, I would be like, nah, right? Because I would know, right, the percentage is more like 65, okay? So we see, without a doubt, though, that there is a lot more black people being booked in jail than white. And then there's this, right? So this is also a box plot like we saw before, but I've separated it by black people versus non-black people. So I'm trying to look at the distribution of days spent in jail, okay? So in other words, I'm trying to see kind of on a distribution level, are black people tending to be on the sort of higher side of days spent in jail versus non-black people, right? Okay, so we see, at least in terms of outliers, right, we see black folks are definitely at the upper end of the outlier piece, right? Almost spending about 400 days in jail, some black folks, right? Whereas some of the white folks are spending a max around 300, right? So that's kind of that's like almost 3 months longer, okay? Kind of based on the outliers, black people are spending like 3 months longer than in jail than non-black people. Now, this is not a good graphic though, right? Why would I say it's not a good graphic? Can I see the box plots really well from this graphic? No, right? It's really smudged down here at the bottom. I can't even tell what the non-black distribution really is, okay, based on this graphic. And it's primarily because there's so many outliers, right? The number of days it takes up a really big range. So if I want to talk about the distributions, I probably want to actually look at the actual statistics, right? The actual measures, Okay, so I see this is like what we call a summary, or like a 5-number summary for any particular distribution, right? So we see the minimum, okay, for both groups is about 0.04 days, meaning basically a few hours, right? But the maximum, okay, is much higher. So 406 for black folks, 321 for for non-black folks. And we see, look at the means, right? The average time black people spend in jail, or days spent in jail, is about 21, 22 days, right? And then for non-black people, only half that, basically, 11 days, right? So that kind of helps our understanding, right? I mean, it also makes us, at least for me, it makes me like very leery of the penal system, right? Like, it's not just that black people are supposedly, doing bad things or, committing crimes, but it's also that there seems to be a focus, for police to really make sure that black people are being punished for committing these crimes or doing bad things, right? I think that's something we want as a society we should take a closer look at, right? And it also makes me not want to spend time in jail, right? I mean, if I ever do something bad, I would hate to get caught because I'm going to be punished way more severely, at least in a statistical sense, right, than my non-black counterparts. So it's kind of a scary stat. It's kind of a scary feeling to be black, at least in Champaign County, but surely in the whole country, right? Or maybe in the world. It's a little bit scary, right? Because for some reason we're being punished quite a bit. As far as a statistical method for this data set, something we could do is, if I wanted to look closer, right, make a more statistical kind of conclusion about this data set, right, in terms of looking at days spent in jail for blacks versus non-blacks, right, I could use a hypothesis test, right? I could basically say, with a certain probability, okay, that, whether black people are black people are spending either more, about the same, or less time in jail, right, than their non-black counterparts. So that kind of test we can use here in this case would be a Wilcoxon rank sum test. You probably haven't heard of that before. Sometimes it's called a Mann-Whitney test. The other idea, right, so this is only useful if the distribution is not normal. Meaning if we looked at the box plots like we saw here, right, so if this distribution was more evenly spread out, right, and the whiskers were more kind of elongated and had this kind of nice fair spread, right, we would be able to say that roughly those two distributions are normal, right, normal distribution meaning like bell-shaped. Okay, and then we could then use a 2-sample t-test, right? But because these are not normal, we have to go a little bit on the more general kind of test, which is a Wilcoxon rank sum test. So basically that idea is I can look at all the observations in each distribution, or for each group, for the black folks and the non-black folks, and I can basically rank the number of days that they spend in jail. So if they spend a lot of days in jail, that would be ranked really high, like a high value. So 406 might be 406, right? But small values will get small ranks. And then I would look at those two distributions side by side, and I would start to compare them. And then I'm saying, okay, is this rank higher than this other rank? If that's true, I would add up the number of times that happens. That gives me a rank sum, all right? And then I could use statistical tables to talk about the p-values associated with that outcome. So in R, we can use this Wilcoxon rank sum test function, okay? And what you want to look at or focus on is this p-value, this p-value here, all right, 2 to the negative 16 power, right, which is really close to 0. Right, so this is saying, in conclusion, right, this is saying that, okay, among the residents in these two towns, Champaign and Urbana, black folks tend to spend more days in jail than their non-black counterparts, right? Based on this type of hypothesis testing, okay, for the two distributions. And that p-value was really, really small. I put less than 0.001, but clearly it's much smaller than that, all right? So we're rejecting the null, right? The null is that the two distributions are basically the same, okay, or tend to behave the same. I reject that null, okay, in favor of this alternative, which is saying that the distribution for black folks in terms of days spent in jail tends to be larger than the distribution for non-black folks. All right? So that's one sort of data analysis project that you can think about. Any questions about that? I can move on to a second one, but yes.
Yeah, I'm very thankful for the research that you're doing and the data analysis, excellent work. I know there are several questions that arise. One is, what is causing the extended stay in jail? Is it because they cannot afford bail? Mm-hmm. Is it because they are denied bail? Is the system inherently biased? So it looks like there's even further study to be done.
Yes.
Yes.
Exactly. Yes. Yes. So as statisticians, right, we or data analysts, we may not be able to answer those questions like in a kind of initial study like this, right? We would need help. That's why we need a team of people, right? We need help from sociologists. We need help from criminologists, policymakers. We need to work together, right, to figure out the even deeper questions, right? So I'm saying, based on this data set, I can say only this much, right, that black people tend to spend more time in jail than their non-black counterparts. What's deeper is what you're asking, which is what systems are in place that allow for that kind of thing to happen, right? Why are black people kind of systematically being punished more severely than their non-black counterparts? Those are deeper questions you would need, more variables on, right? So this data set, I would probably need more information like kind of more systematic information, which is harder to get, I think. But those are great questions for this kind of project. You would want to definitely explore further. Yeah. Any other questions before I move on to the next project? These are just, and I don't have to move on if you have more questions, but this next piece then I think might be interesting for a larger audience. What this idea is at least what I'm going to talk about is a little bit less on the statistics side, more on the humanities, literature side. Basically, I want to ask you to do a lot of the interpretations of things once I kind of show you the graphs, right? But this might be a little bit more interesting. So this next project was on Martin Luther King speeches or quotes. So basically, I found 39 quotes. Okay, they're supposed to be unique, meaning they're not the same quotes, over the span of his life, or in some sense his life, right? From 1947 to 1968. The earliest quote is from 1947, which is a part of a writing and oral kind of presentation he did as a high school student. All right, so these are things he said or wrote. It's in the form of text, so every sort of data entry is a line of text. Right, so it's very different from what we did before because now we're talking about a totally different kind of data set. The structure is gone now, right? So this is unstructured because I don't have, like in its original form, I don't have rows and columns, right? I don't have, any matrix, data frame, array, anything like that in its original form. All I have is I have 39 separate text files, okay? And then what I have to do is analyze those text files as a data scientist now. I'm putting on a different hat. So before I was a statistician, now I'm a data scientist in some sense. Okay, so what I'm trying to do is analyze this kind of data set. And in its raw form, right, there's 1,620 words. So these are not very long quotes. And basically about 7,700 characters, okay, if you don't include the spaces. And so the purpose of this kind of project is I'm trying to just investigate who really was, or who was Dr. King really? Meaning, like, was he a hopeful person or was he a hopeless person? I'm trying to use the computer to decipher through his quotes the kind of tone he might have had going from 1947 to 1968. So using his quotes to kind of learn more about him, right, since I don't personally know much about him and since the computer doesn't know anything about him, in its raw form, okay? So this is what we'll call text analysis, all right? And this is just a snippet. So we have 2 quotes here. Take a second, read them for yourself, right? And then I'll ask you a couple questions. Okay, so does he sound hopeful in either of these quotes? You said the top one. He sounds hopeful in the bottom one? The top one. Okay, so you're saying he sounds hopeful in the top one, right? I would say yeah, right? I mean, just me, right? Not the computer. I would say probably right? I mean, he doesn't say anything very critical here. He's not like, saying negative words really. He's saying, intelligence plus character, that's a true goal, or that's the goal of true education. All right, the second one though, sounds a little not too happy, right? He's talking about cruel, he uses the word cruel, irony, right? He uses the word kill and die, unable, okay? He's talking about, education, the Board of Education and issues with education versus, the U.S.'s stance on the Vietnam War, right? I don't have a whole lot of time, but I'm gonna try to get through some aspects of this, and then I'll stop, because I know we have to get out of here for the next class. But some questions you might have for this data set is, you might have like, how many times will certain words appear, right? And for instance, how many times did the word think appear in that first quote? It showed up twice. Are there other words that appear frequently? If you could pair certain words together, do certain words make more sense together than others? Does he seem hopeful or hopeless, right? Does he seem positive or negative in those words that he's using? Okay, and then you could even go further and say, like, can I compare all of these ideas in 2 different time periods, right? Like, is he like happy in his earlier life and kind of, regretful or sorrowful in his later years? Like, these are all kinds of things we can think about, and then how can we use a computer basically to get there? So this is what I'm saying is text analysis. So basically, I'm trying to extract important features, okay, from documents, right, without having to read the documents myself. So the idea is, in a real text analysis project, you will have a ton of documents, 10,000 different documents, maybe 1 million documents. And what you're trying to do then, right, because you definitely can't read 1 million documents, you're trying to say, okay, can I use the computer to sort of piecemeal give me the most important things that are being said in this document, right? For instance, in a book that I was using to kind of create these slides, The author was a data scientist who was hired as a consultant to work for Delta Airlines. And what he was doing was he was tasked with the idea to use tweets, okay, from customers to figure out how like what things that Delta can do better, right, in terms of their customer relations, right? And so, you know, every time a person tweets and then puts a little @Delta, right, then that would be stored for this particular person, and he would go back and say, okay, I have this in my data set now. All right, so text is unstructured, right? You want to do it on a large collection of documents. And what you have to do as a data scientist is to then organize that data and then analyze it. And there's a lot of different pieces of analysis we can use. What we'll talk about very briefly will be the frequency analysis part of that. So the procedure is similar for any data analysis, right? You start with the problem, make some goals, but in this case you have to actually get the documents, right? Or which is like assessing the data. You have to clean it, which is what we did before, but you have to do different things to clean the data set. So we'll be lowering the words all to lowercase. We'll remove punctuations, numbers, white space, and stop words. And I'll talk about what those things are. So I'm gonna just really quickly just get through this last piece. So stop words, just for people who don't know, they're basically words that aren't informative, like in the English language. So words like articles, right? Like the, a, and, you know, some certain prepositions like for, of, you know, if. These things may not be that informative because a document may have those words show up thousands of times, right? So you would want to remove those very, very common non-informative words when you're doing a text analysis. Okay, so the method that we're going to talk about really quickly, like I said, is frequency analysis. So, and that's kind of where like the basic stat could come in, because you know what a frequency is, right? You know that it's basically the occurrence of an event, right? So we want to basically count up the number of times a particular word appears, and we want to visualize that and then draw some conclusions from those visualizations, okay? So let me just go to this part. All right, so this is called a word cloud. How many people have seen a word cloud before? Everybody. Oh, okay, all right, everybody. All right, so then you know how to analyze this, right? So what can you say about this word cloud based on Dr. King's words in these quotes? Anybody? Just common knowledge kind of. I'm not looking for deep things here. I'm saying everybody has a brain. You look at this image, you're trying to figure out relationships, you're trying to figure out anything that jumps off that looks interesting, right? You're viewing this graphic for the first time. What jumps out at you?
White.
White. Okay, white jumps out at you. Why does white jump out at you? It's the largest. Somebody said it's the largest, right? Exactly. Just like Will, right? Will and white have the same color, right? They're the same size, which means what then? Is used the most, right? In these 39 quotes, he uses the word white and will quite a lot, okay? More than the other words. What else jumps out at you? Justice, okay. Because it's the only one that's green. What did you say in the back? It was okay. It's brighter. Okay. Yeah. Fine. All right. So it's the size of the font is actually a little bit smaller than the font that's in yellow, right? So in some sense, it's basically up there in terms of frequency, but not as frequently appearing as Will and white. What else jumps out at you? I hear people say something about Negroes. Some people say about life. Okay, right. So you're looking at the words in purple, right? So those are like I said, the next most frequent words, right? And then you have then it's the blue words, and then it's the least frequent ones, which are in orange here. Right. Right. So yes. So he's using the words white and will a lot, along with justice. And that's also being shown in this, if I go back here, in this bar plot, right? So the bar plot may not be as cool looking as a word cloud, but it's in some sense telling us what we just saw, right? White shows up the most, then will, then justice, then you have life, love, must, and Negro all in there, right? So what do you think about then when Obama uses words? So Obama uses words in the State of the Union address, 2010, 2011. He uses will the most, right? In those two speeches, among those two speeches, right? So in some sense, he seems hopeful, right? MLK, Martin Luther King, they seem a little bit hopeful, right? Because they're looking toward the future. They're saying will. Some things maybe will happen, or it will change, or it will do this, right? It will, right? Right? Okay. I'm going to stop there. And yeah, so in summary, basically data analysis can be very informative. All right, text analysis can be also informative up to a certain point, right? So, you know, you won't be able to draw maybe the same kinds of numerical sort of conclusions that you can with the more numerical data, but you can draw some insights, okay, from text. All right, that's my baby. Okay, so I used R. I'll just show you real quick what R looks like here to do. All right, so this is what R looks like, okay? It's a very plain Jane looking piece of software, but it is very powerful, okay? So we used R basically I used R to show you all those graphics, except the ones at the very beginning, because those were not graphics that I made, all right? But in this software, basically, on this side, on this side here is where I would write my code. And then on this side is where my results will show up over here. This is called the console, okay? So just want to show you that. I didn't get a chance to do more. But basically, we can draw information from text and data, and there's a lot of room for improvement, meaning you can, you know, in statistics, in data science, if you want to take this up as a research area, right, there's a lot of room for you to do that, right? That could look like projects, that could look like papers, you know, but there's a lot of room, especially for black folks, because there's not many of us there. All right, so I'm done. Thank you for your time, and if you have some questions, you can ask now.